Now we're going to do in 1.5 rewriting equations and formulas. This is where we're just going to get a lot more practice. So one vocabulary word that's going to come up in this lesson is the phrase literal equations. What that means is just any equation that has two or more variables, which is what we just worked on in the exploration lesson as well. But it's important that when you see the phrase literal equations, you know it's just referring to something that has more than one variable. Here, in these first three examples, we're solving our literal equations for y. So our goal is just to get this y by itself. We're going to use all the same strategies that we've used in the past, but now we have two variables. So here, I want to get this 4x away from my 3y. So I'm going to subtract it. And we want to start with our x term first. You'll see why later in the year as we progress. So always start your equation, if you're solving for y, having the x term come first. So notice here, when I subtracted 4x, I needed to make that into negative 4x, and then it was a positive 9. Now I have 3y, but I just want to have 1y, so I'm going to divide both sides by 3. Notice I'm dividing everything by 3, big division sign. These cancel out. That's the whole reason why we were dividing by 3. So y equals, and you have two choices. One is to split them up, which I'm going to encourage you to do. And like we talked about in the last lesson, you can leave it as negative 4/3. And then the 9 is also being divided by the 3. So the sign comes from this plus, so plus here, and then 9 divided by 3 is 3. So we have y equals negative 4/3 x plus 3. Number 2, we'll bring it over so we can see it more closely. Now this time, the y is on the right side. So you can solve it the way it is right now, or if you wanted to, you could switch the left and the right side so that the y ends up being on the left side from the beginning, which we can do it at the end. It doesn't really matter. So again, we're trying to get y by itself. So I'm going to subtract that 8x because it's a positive. And I'm going to lead with my negative 8x plus 20 equals 4y. I'm going to divide by 4. And now this is going to be one that I definitely do want to simplify. So negative 8x divided by 4 is going to be negative 2x plus, because it was plus 20, 20 divided by 4 is 5 equals y. Now we want it to be y equals, so y equals, and then start with my x term, negative 2x plus 5. Go ahead and try number 3 on your own and then come back to check. Okay, you can see I subtracted 4x from both sides, and then I made sure to bring down my negative here. And then I divided both sides by negative 7. So this is one place we need to be careful. I have negative 4 divided by negative 7. So that's going to give me a positive 4/7 x. Notice the x I put on the side. And then I have positive 12 divided by negative 7. So that's going to become a negative. And 12 is being divided by 7. So I'm going to write it like a fraction like that. Notice I'm not trying to do anything with decimals. It is perfectly okay to leave it as a fraction. All right, the next part of this lesson is about rewriting formulas. It's the same concept as what we just did, but starting with a common formula. You'll see this orange note here. It is up to you. You decide what you want or not. You could choose to do this whole next section in your toolkit, or if you wanted to just copy these formulas into your toolkit, you could, and I would name it as your title in your table of contents and at the top of your page. You could just call it common formulas. And if you choose to do the examples in there, then maybe you would add common formulas and rewriting or something along those lines. This is on page 38, so if you need it larger, you can go ahead and look at that in your textbook. All right, number 4, solve the temperature formula for F. So first thing I'm going to do is just copy it down. And I want to get the F by itself. Remember, we're going to use the reverse of the order of operations to kind of peel away our layers to get down to my variable that I'm solving for. So the thing I need to deal with first is this 5/9. So to get rid of that 5/9, it's being multiplied. I could divide by 5/9. And a reminder, when I divide by a fraction, I can always multiply by the reciprocal. So the reciprocal is 9/5. So I'm going to multiply both sides by 9/5. So I have 9/5 C equals, and these make a 1. That's why I'm doing it in the first place, F minus 32. And so now I can add 32 to both sides. And this equation is very helpful if you ever get the opportunity to travel someplace where the temperature is in Celsius. You will need to know this so you can try and figure out how hot or cold it's going to be when you look at the weather. When I studied abroad in Spain, I walked by a bank every day that had the temperature in Celsius, and so I was always trying to figure out what that meant in Fahrenheit so that I understood how hot it was going to be or what the high was going to be. All right, now we're going to use the interest formula. So interest formula is the interest will equal the principal, that's the amount of money you start with, and this is simple interest, that's a capital P, times the rate, the interest rate times the time, how long you leave it there. And notice the interest is always in years. So we're solving for R. R is being multiplied both by P and T. So it's kind of similar to one of those problems in the exploration where I divided by both the values it was being multiplied by at once. I like to put a little kind of umbrella hook on my T, a little curve on the bottom so it doesn't look like a plus sign. And so I have I over principal and time equals my rate. You deposit $5,000, so that's going to be my principal, that's my starting amount, in an account that earns simple interest. After 6 months, remember I made a big deal a minute ago about how the interest is always, or the time is always measured in years. So this is a place where students might make a mistake. So 6 months is really going to be 1/2 of a year. We need to pay attention to that. And it earns this much interest. So that's going to be my I. In the year that was T. So I'm going to try and find the rate, and that's always going to be represented as a decimal. So here I have my interest that I solved before over my principal times time equals my rate. So my interest was $162.50. My principal was $5,000. And my time was 1/2 of a year, 0.5, or you could do a fraction, and that will tell me my rate. So I'll take my $162.50. Half of 5,000 is going to be 2,500. And then we can go ahead to divide. So 0.065 equals my rate. This is representing it as a decimal, but then we always describe our rates as a percentage. So to change a decimal to a percent, a reminder, you move it over 2 spots. So this is going to be 6.5%, which would be awesome. Most of our savings accounts right now maybe are earning 1%, probably even 0.5%. So 6.5%, if you can find that, you should take it for a savings account. All right, you deposit $3,500 in an account that earns 4% simple interest. How long will you have to leave the money and how long? So we're looking for T. We're going to be solving for time this time to earn $350 in interest. So let's start with our equation again, our formula, I equals PRT. And I want T this time. So I want to get T by itself, which means I'm going to divide by P and R at the same time. Okay. And my interest that I'm looking for is $350. My principal was $3,500. And my rate was 4%. Again, 4% we need to change to a decimal. So then you move it there's an invisible decimal behind your 4. So you have to move it 2 spots to the left to go from a percent to a decimal and fill in the 0 there. So my rate is going to be 0.04 because that is what 4% is as a decimal. And then we can go ahead and do our multiplication for the denominator and divide. All right, and then we go ahead and we get 2.5 equals T. And remember, time we said was measured in years, so 2.5 years. Again, a 4% interest rate would be great. All right, and our last example, Dan drove 330 miles at 60 miles per hour. So this is dealing with distance, rate, and time. So that equation is D equals R times T. Distance equals rate times time. Ryan drove 275 miles at 55 miles per hour. So we're comparing two different people. How much more time did Dan drive than Ryan? So first, it's telling us to solve the distance formula for T. R and T are being multiplied, so I can divide by R. So D over R, distance divided by rate, will tell you how long you're driving. And then we are comparing the two people. So Dan drove 330 miles, that's my distance. At 60 miles an hour, that's my rate, and that will tell us his time. And then Ryan drove 275 miles at 55 miles an hour, and that will tell us his time. Let's give him. So then we can simplify each of those, and then we can compare them. Okay, so Dan ended up driving for 5.5 hours, and Ryan ended up driving for 5 hours. The question to remind you was how much more time did Dan drive than Ryan? So the difference between the two was only 1/2 of an hour, or 0.5 hour more.